Hi students, welcome back to Konnur's online video classes. Yesterday we are discussing about rational, irrational and some kinds of rational numbers, terminating, non-terminating or non-recurring. We are already discussed. Now today we are discussing about represent on the number line some decimal expansions. And the first one is, now this is exercise number 1.4. The first one is visualize 3.765 on the number line using successive multiplication. It means this is a very simple problem. Now you already know about the number line, but you have to concentrate the given number. The given number is 3.765. Now first you have to identify 3.7 is lies between the 3 and 4. No? That's why the first step is 3.7 you identify. 3.7 is lies between 3 and 4. That's why first you draw the number line. This is the first step. Now here is 0, 1, 2, 3, 4, and here is minus 1, minus 2, minus 3, and minus 4. Minus 2, minus 3, minus 4, 1, 2, 3 and 4. Now this number line, first you identify 3.7. Now 3.7 is in between 3 and 4. No? That's why here is 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. Now 3 and 4 between 10 digits are there. Each digit is a 0.1 measurement. That's why first one you have to identify the given 3.7 is lies between 3 and 4. The next identification is 3.7 you identify specifically here. 0, you take here 3 and 4. 3 and 4 you have to identify it. Now 3 and 4 in between how many digits? 10 digits. That's why you take 3.1, 3.2, 3.3, here is 3.4, 3.5, 3.6, 3.7, 3.8 and next one is 3.9. Now the first number is, the first digit 3.7. Here 3.7 is in between 3 and 4. 3 and 4, 10 digits are there. That's why you have to identify this is equal to 3.7. This is the second step. And the next, this third step is 3.76. 3.76 is in between here 3.7 and 3.8. That's why now you draw it, the another step. Now here is 3.7 and here is 3.8. 3.7 and 3.7, 3.7 and 3.8 between, again you have to mention 10 digits. Then you have to identify 3.76. Now here is 3.71, 3.72 and 3.73, and here's 3.74, 3.75, and here is 3.76 and 3.77, 3.78 and 3.79. The next digit is 3.8 is followed. Now according to the given decimal expansion 3.76, no, here 3.76 is here. This digit identification is 3.76. Now you have to write 3.76. And but the one more digit is also there. The one more digit is 3.765. 765 is in between 3.76 and 3.77. That's why the another step you take the another number line. This number line is between 3.76 and 3.77. Now again 3.76 and 3.77 between you have to mention the 10 digits. Here 3.761, 3.762, 3.763, 3.764, 3.765, 3.766, 3.767, 3.768 and finally 3.769 and next digit is 3.77 is formed. Now the given decimal expansion is 3.765, that's why here this digit is 3.765. Here you write 3.765. Now this is the representation of the number line of the given decimal expansion. Here the first step, first you identify first digit. Second step, you have to identify the second 3.7 value, and the next one is again you have to identify 3.76 in between 3.7 and 3.8, and the next one is the given number is a 3 digits, that's why 3.765. Now 3.765 is in between 3.76 and 3.77. 3.76 and 3.77 between you have to mention 10 digits. Then you have to identify 3.765. Now this is the magnification of the given decimal expansion. And the second one is also very simple. On the basis of similar problem you have to do it, but I have explained this one. You have to do it. Now first I have explained. The second question is visualize 4.26 bar on the number line up to 4 decimal places. Now up to 4 decimal places means what? Here the given is 4.26 bar. Bar is related to the 26, no? That's why the 26, both the digits are repeated continuously. It means here 4.26, 26 and so on is formed. Why we write only 4 digits? Because according to the given problem, only 4 decimal places. 4 decimal places it means you have to take 26 and 26. Only 4 digits you take. Similarly, you have to do it this magnifications. Now first you identify 4.2. The 4.2 is in between 4 and 5. Again you have to draw the number line and then you mention the 4.2. And the second step is 4.26 and again 4.262 and finally 4.2626. Now similar procedure you have to do it here. Same procedure, but the given decimal expansion is 4.2626. Now this is the homework, you have to do it. This is a very simple. Now the next one, next exercise 4.5. In a 4.5 some examples are there. The examples are also very simple. Now you concentrate. Here classify the following numbers on rational or irrational. Now this is a very simple question. The first one is 2 minus root 5. Here the first one 2 minus root 5. Here root 5 is a irrational. Now 2 is a rational number. Now subtraction of any rational to irrational, we get the result is equal to irrational only. That's why now this is an irrational number. Irrational number. Now second one. The second one is bracket 3 plus root 23 minus root 23. Here first you remove the bracket according to the procedure. Here minus sign you multiply it, or you don't multiply directly, you take, you remove the bracket 3 plus root 23 minus root 23. Now plus root 23 minus root 23 get cancelled. Remaining is value is only 3. 3 is a rational. That's why 3 is a rational. And again we observe the given problems. Third one, 2 by 7. 2 root 7 divided by 7 root 7. This is also very simple. 2 into root 7, 7 into root 7. It means both are multiplicative terms we observe in the numerator and denominator side. Here this is a radical and this is a radical sign and this is coefficient. This is a procedure of surd. Now root 7 ones are remaining is 2 into 1 2, 7 into 1 7. Now the value is 2 by 7. 2 by 7 is in the form of an rational p by q. That's why this is also rational. And the fourth one is very simple. Directly the given term 1 by root 2. Now 1 is a rational but root 2 is a irrational. Now division of any rational to irrational, we get the irrational only. That's why this is also irrational. And the fifth one is 2 pi. Now here is also you observed 2 pi. Pi is a irrational and 2 is a rational number. Multiplication of any rational and irrational, we get a irrational only. That's why this result is also irrational. Now this is the first one in exercise 1.5. Next question, second one, simplify each of the following expressions. The first question is 3 plus root 3 into 2 plus root 2. Now this is a very simple problem. Multiplication of binomial to binomial. Here the first one is a binomial term, second one is also binomial. This procedure is called multiplication of binomial to binomial. Now this is a very simple. By using the multiplication procedure, you have to multiply directly or you take one more step. Now the first one is 3 is multiplicative to both the numbers. That's why 3 into 2 plus root 2 and plus root 3 is also multiplicative to both the numbers. That's why you take root 3 into 2 plus root 2 plus root 2. Then you simplify. This is a very simple question. 3 into 2, 6. Next, here is also positive, positive into positive, positive. But here is a rational number, this is irrational number. Directly you don't multiply 3 into 2, root 6. Don't write it because this procedure is completely wrong. Now, multiplication procedure is you have to multiply irrational to irrational, rational to rational, rational to irrational. The procedure is here 3 into root 2, 3 root 2. And next one, plus here is a rational and this is an irrational. Now 2 into root 3, 2 root 3 and plus into plus, plus here both are irrational numbers and the multiplication of irrational numbers procedure is same order. Now here is a square root and this is also square root. You multiply directly. This radical sign is changed. You don't multiply the irrational to irrational because the procedure is wrong. Now root 3 into root 3, root 6 because both the radical sign root these are this is a radical sign. Now root 3 into root 3, root 6. Now Here you observed all the terms. Here is 6 is irrational, it's a rational, plus 3 into root 2, 2 root 3 plus root 6. Now you don't add these two. Addition of irrationals or addition of surd. These three terms are in the form of an surd. That's why addition of surd rule is here. The third concept I have to discuss, explain. Here, surd means the given numbers are in the form of an irrational. Now, surd definition is irrational root of a rational number. Now, 6 is a rational, but root of 6 is a radical sign. That is an irrational root. Now, here, irrational root of a rational number is a definition of a surd. Irrational root of a rational number. Rational number. This is the definition of surd. Now the general form of an surd is now nth root of a. Nth root of a is the general form of an surd. Now in this form, a is a radicand. A is a radicand and n is a root n. Nth root is equal to is a radical sign. Radical sign. Now, by using the procedure of addition of surd is same order and same radical. For example, root 2, 3 root 2. Now, root 2 and 3 root 2. These two are in the form of an surd, but both are square root. Is a radical. Both the radical sign are same and radicands are also same. 2, 2. That's why in this type of surds we directly add in here. This coefficient is 1, 1 plus 3 is equal to 4, 4 root 2. Now this is the procedure of addition of surd. Multiplication means both radicands are different and both orders are same. Now this is the procedure of multiplication of surd. And this is the answer of the first question. And second one. The second one is now 3 plus root 3 minus root 3. Now generally you observe these two terms. Here is a and this is b. A plus b, a minus b form. Now therefore a plus b, a minus b is equal to a square minus of b square. According to this problem, a is equal to 3 and b is equal to root 3. Then directly you put it in identity. Now implies 3 plus root 3 into 3 minus root 3 is equal to a square minus b square. A means 3 square minus root 3 whole square. Now you simplify. 3 square is 9 minus square and root get cancelled. Remaining is only 3. Now this question solution answer is 6 only. Now the next question. The third one is root 5 plus root 2 whole square. Now here is a and root 2 is a b. A plus b whole square form. Now therefore a plus b whole square is equal to a square plus 2ab plus b square is a standard identity. Now a is equal to, according to the given problem, a is equal to root 5 and b is equal to root 2. Now you put it here, implies root 5 plus root 2 whole square is equal to a square, a means root 5 square plus 2, a means root 5, b means root 2, a 2ab form. Then next one is b square, b means what? Root 2 square. Then you simplify, square and root get cancelled, and here is also you take square and root get cancelled. Remaining terms are 5 and 2. 5 plus 2 is equal to 7, plus here you observe in the 2ab form, here is also both are root 5 and root 2, both are third form. Multiplication of third rule is both are the same order. Here is also square, here is also square root. Both are order, radical signs are same or orders are same. Directly you multiply 2 as it is, you write 5 into 2, 10, root 10. This is the solution of the third question. And next one, the next one, fourth one, root 5 minus root 2, root 5 plus root 2. Now this is also very simple by using a minus b and a plus b identity is equal to a square minus of b square. Here you take a minus b, a plus b is equal to a square minus b square. Therefore, according to the given problem, a is equal to root 5, b is equal to root 2. Now, you have to apply the standard identity. Root 5 minus root 2 into root 5 plus root 2 is equal to a square minus b square. No? A means what? Root 5. Here you take root 5 whole square minus b square. B value is root 2. Root 2 square. Root 2 square. Now you simplify, square and root get cancelled. Here square and root get cancelled. 5 minus 2 is equal to 3. 3 is the solution of the fourth question. Now again, third one, main question number 3. This is a very simple question. Now you have to observe. Third question is here. Recall phi is defined as the ratio of circumference, say C, of a circle to its diameter, says D. That is, phi value is C by D. This seems to contradict the fact that phi is rational. How will you resolve this contradiction? Now it's a very simple question. Here, circumference of the circle is equal to, circumference of the circle we denoted by according to the given problem C. Circumference of the circle is equal to 2 pi r. This is the formula. Circumference of the circle is equal to 2 pi r. Now C is equal to, now rearranging the terms, 2r into pi. 2r means what? 2 times of the radius. 2 times of the radius is equal to, is always diameter. That's why C is equal to d pi. Therefore, pi is equal to C divided by, now C is equal to, yes, here pi value is equal to, because according to the given problem pi is equal to C by d. That's why pi is equal to C by d. Now this is already given, but you know how this form is formed. You check it. Pi is equal to C by d. Now generally you observe, you already consider pi value is irrational, is a non-terminating or non-recurring, and C by d is not exact value, is approximate value, but C by d is a rational number but not exact value of pi, because pi is a irrational number. Pi is a non-terminating, non-recurring number, and C by d is in the form of a rational, but we consider only approximately. That's why now pi is equal to C by d is formed. Now Again, the fourth one, this is also very important in examination point of view, you concentrate it. Now, represent root 9.3 on the number line. Now, this is a very simple procedure, you have to follow it. Now, fourth one is root 9.3. See, according to the procedure, you take a scale and pencil, then you arrange 9.3 centimeter. You arrange 9.3 centimeter. You arrange 9.3. Here, this length is 9.3. And according to the procedure, the given line we are extended 1 centimeter. Here, the first procedure is according to the given problem 9.3. You have to arrange by using a scale. Then again, we are extended 1 centimeter. 1 centimeter we are extended according to the procedure. Now the end point we considered C. And the total length is 10.3 is formed. The total length is 10.3. AB length is 9.3 is formed. Now, by using a compass, we are bisecting the line of AC according to the side bisecting procedure. By using a compass, AC length, according to the AC length, more than half length you consider, then draw the arc upper side and lower side, same length, the another end point as a C, then you draw the arc upper side lower side, then you join it to both the points, then AC is bisected, this point as I have considered M. Now according to the side bisecting procedure, AC is bisected, AC midpoint is M. Now again by using the compass, M point as a center, then arrange AM or CM length, AM or CM length, AM or CM length, draw the semi arc. That arc is on A and C. And the next point is on the B point through you by using a protractor. You mention 90 degree and you join it by using a scale. By using the scale, you draw it. Then again this point has a P. Now by using scale, you measure the BP length. The BP length is root of 9.3 is formed. That's why you have to do it, because BP is approximate values are there. That's why you have to follow this procedure. You get the root of 9.3 value. Yes.